Now Unit 12, some basic principles of organic chemistry. Well, first of all, we should understand a little bit about chemical bond. The attractive force which holds various constituents together in different chemical species is called chemical bond. Types of chemical bond. There are mainly principal bonds and subsidiary bonds. There are 3 principal bonds and 3 subsidiary bonds. Principal bonds are metallic bond, ionic bond, and covalent bond. Subsidiary bonds are coordinate covalent bond, hydrogen bond, and van der Waals force of attraction. Covalent bond. When 2 atoms share electron pair, a covalent bond is formed between them. Lewis and Langmuir proposed the dot structure of molecules. Suppose hydrogen has single bond, that can be represented like this, that you can put 2 dots between 2 hydrogen. That shows that there is single bond between 2 hydrogen. Fluorine has single bond, but it is necessary to show lone pair of electrons also. Like fluorine has 1 bonding capacity, so it can form single bond, but there are 7 electrons in outermost cell, but we have to show all 7 electrons. There are 3 pairs and 1 unpaired. The unpaired electron form a bond, but these pairs remain as it is. These pairs are known as non-bonding electron pair, or lone pair of electrons. So they cannot form covalent bond, but it is necessary to show it, and you can see that by bonding electron pair, this is bonding electron pair, and they will form octet. Chlorine, single bond, but there will be 3 lone pairs, and therefore there will be octet. Similarly, HCl. HCl has single bond, and you can show it like this. Well, these 2 atoms are of different elements, therefore we can use different symbols to show electron. Cross is electron of chlorine, dot is electron of hydrogen. So that is single bond, and therefore we can put 1 dot 1 cross and 3 lone pair of electron of chlorine. O2. O2 has double bond, so we can show it like this. When there is double bond, each atom provides 2 electrons for sharing, and therefore total 4 electrons are shared, and each oxygen has 2 lone pair of electrons. Nitrogen has triple bond, so that can be shown with this way. You have to put 6 electrons between 2 nitrogen. Each nitrogen provides 3 electrons for sharing, and therefore triple bond appear, and nitrogen has 1 lone pair. H2O, there is single bond between hydrogen and oxygen. So this way you can show it. NH3, 3 single bonds between hydrogen and nitrogen. So this way we can show it. CH4, dot structure of CH4, 4 CH bonds. Now valence bond theory. Lewis structure cannot explain everything about this covalent compound, and that is why it is necessary to know with different concept. So valence bond theory explain the bonding with orbitals. For example, 1s orbital of hydrogen, and there are 2 hydrogens, so we take 2 1s orbitals of 2 hydrogen. They attract each other, so they come closer and they overlap. This is common area for both. Now electron pair remain in this area only, and 2 nuclei attract them Therefore, this is SS overlapping, and direct overlapping form one electron cloud, so it is called sigma bond. So hydrogen molecule has sigma bond. HF. Fluorine provide 2pz orbital, hydrogen is having 1s orbital. These two orbitals overlap and form a bond, and this is called sp overlapping, again direct overlapping, form sigma bond. So HF is having one sigma bond. Fluorine, two 2p orbitals, they directly overlap with each other and form one sigma bond. This is called pp overlapping, and it is F2 molecule. Oxygen, O2. Each oxygen has two unpaired electrons in two different orbitals. One is 2pz orbital, which is on z-axis. Another on 2py orbital. Another is 2py orbital, which is on y-axis. So first of all, direct overlapping takes place of these two 2pz orbital on z-axis, and they will form one sigma bond. So this is sigma bond between two oxygen. But 2py orbital remain perpendicular to z-axis and parallel to each other. Each one has one unpaired electron and the spin is opposite. So definitely they will attract each other. But see, this is 2pz orbital, this is 2py orbital. 2pz, 2py. When two oxygens directly approach each other, there will be overlapping on z-axis. So 2pz, 2pz overlap with each other. But how come 2py, 2py overlap and form pi bond? And you cannot change angle. You cannot show it like this because you are tilting the y-axis, and you can't show that two y-axes are crossing each other. So this type of overlapping is not possible. Either you have to break sigma bond and show the overlapping of 2py like this, but practically only one orbital is overlapping, but these two 2py orbitals remain parallel and they will not overlap. Then how the bond is formed? Well, exchange of electron takes place from one orbital to another, and there will be electron cloud over here in between these two. This is called pi bond. So when direct overlapping is not possible, a new bond is formed which is called pi bond. Okay, and this type of overlapping is called lateral overlapping. Or sidewise overlapping, and that is pi bond. So when oxygen is formed, there will be one sigma bond and one pi bond. So whenever you put double bond, there is one sigma and one pi. Now nitrogen. In nitrogen, there will be triple bond between two nitrogen. So each nitrogen has three unpaired electrons in three different orbitals. Suppose one of them is 2pz, then remaining will be 2px and 2py. So let us take these two nitrogen. When they overlap with each other, first of all, direct overlapping takes place on z-axis. And there will be one sigma bond. And 2py can overlap. Similarly, 2px can overlap. So this is pi bond. Another pi bond is here. And this is sigma bond. So nitrogen and nitrogen has triple bond in which 1 sigma, 2 pi. So whenever there is triple bond, there is 1 sigma and 2 pi bond. Double bond means both 1 sigma, 1 pi. Single bond means sigma bond. So nitrogen is like this. Now we have to see how many number of sigma and pi bonds are present in a given compound. For example, find out number of sigma and pi bonds. For example, this compound CH3COCH3. So you have to show the structural formula and split each atom. Remember, carbon forms 4 bonds, hydrogen forms single bond, and oxygen forms 2 bonds. So this way we can satisfy. Now single means sigma. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 sigma bonds and 1 pi bond. CH2 double bond CH, CH double bond CH2. So here H, C, H, double bond C, H, single bond C, H, double bond CH2. Sigma bond 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sigma, 2 pi. Benzene. Well, we draw like this, but it is in fact 6 carbon, this way. Now calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sigma, 3 pi. So this way, if any molecule is given, you can find out number of sigma and number of pi bonds. Now we have to draw BeH2. Beryllium, number 4, configuration 2s2, 2px, 2py, 2pz. There is no unpaired electron, therefore bonding capacity is 0. But in excited state, one electron from 2s can transfer to 2px. Now it has 2 unpaired electrons. So one beryllium can join with 2 hydrogen and there are 2 bonds. Okay. Here one beryllium overlap with 1s orbital of hydrogen and 2px orbital of beryllium overlap with 1s orbital of hydrogen. So there are two atomic orbitals of beryllium. One is 2s, another is 2px. Now 2px orbital of beryllium overlap with 1s orbital of hydrogen. So we can show it here. This is 1s orbital of hydrogen, and there will be single bond between beryllium and hydrogen. Now 2s orbital of beryllium overlap with 1s orbital of hydrogen, so it can be above or below this. So this is 2s and 1s orbital, hydrogen 1s. This is beryllium. So this is sp overlapping, and one is ss overlapping. But then in this case, one hydrogen will be on x-axis, another on y-axis, and bond lengths are different because SS overlapping is shorter than SP overlapping. So bond lengths are different, angle should be 90 degree, but it is not possible. Why? Because if you put SS overlapping on y-axis, that means electron of 2s orbital is on y-axis. That means 2s orbital is directional, which is not possible. So it is one of the possibility, but it can be like this also. So there are n number of possibilities of BeH2, and therefore shape of molecule is unknown. But when we put this in X-ray, we can find out proper shape of BeH2. That means this theory, valence bond theory, cannot explain this structure of BeH2. So we need a new theory which was given by Pauling, and it is called hybridization theory. So Pauling proposed theory of hybridization. So according to theory of hybridization, these two different orbitals of beryllium, one is 2s, another is 2px, mix with each other, overlap with each other, and produce new orbitals, and it's a mixture of s and p, and they are known as hybrid orbitals. So these hybrid orbitals looks like this, and there are two hybrid orbitals. If you arrange these two hybrid orbitals, then they will be at 180 degree. So these are known as sp hybrid orbitals. And now these sp hybrid orbitals, which are of equal energy, equal shape, and equal size, they will overlap equally with two hydrogen and form two covalent bonds. Therefore, two hydrogen remain at equal distance from beryllium. So the hybridization of beryllium over here is sp hybridization. In which this sp hybrid orbital has 50% s character. That means it is more like a sphere. Number of bonds 2, bond angle, we have to arrange two orbitals, so it is 180 degree, and shape is linear. So BeH2 is linear, and both bond lengths are equal, and angle is 180 degree. So this is BeH2. It is linear due to sp hybridization. Next is BH3. Here also boron in number 5 configuration 2s2, 2px1, 2py, 2pz. So in excited state, one electron from 2s transfer to 2py, and therefore there are 3 unpaired electrons. 3 different orbitals of boron overlap with each other. One 2s, one 2px, and 2py. These 3 different orbitals of atoms produce 3 hybrid orbitals of boron, and they will be arranged at 120 degree. And these are known as sp2 hybrid orbitals. Which has 33% S character. So they are more like dumbbells, and then they will overlap with 1s orbital of 3 hydrogen. Hybridization sp2. Number of bonds 3. Bond angle 120 degree. Shape planar triangle. So BH3 is planar triangle. Any molecule which is having sp2 hybridization is always like this, and angles is 120 degree.